morning, sir.
So today we'll start with a new topic, which is measure of dispersion. So first of all, what is the dictionary meaning of dispersion? Yes, anyone? What do you mean by dispersion?
Scattering all over the place.
Okay. Anything else?
Value distribution.
Value distribution. I'm asking dictionary meaning of deviation. You're giving me not giving the correct answer in short. Getting spread.
Deviation or dispersion?
Dispersion.
Dispersion.
So like distributing things, it means.
Distributing things. Okay. So I will make a statement now. The statement is I have a data which is having a large dispersion,
Sir, which is spread in wide area.
which is spread in a wide area. Okay.
Has huge number of uh, different types of many numbers. Otherwise,
Okay. Different types of many numbers. So first of all, I will just write this down. Dispersion. Say I have the heights of say 6 people, and I'm taking the integer values. So the heights are say 2, 5, 7, 6, 4. This is one set of 6 people, and these are their heights, the integral values I've written. And the another set I will write it down here as say 3, 4, 5, 4, 3. I have two set of people. In each set there are five people, and I have written the heights. Now my question is, which is having higher dispersion? Which set is having higher dispersion?
The first one.
Why?
It has many unique values and they are not consecutive.
Okay. Consecutive. Okay, fine. So in the first set, as we can see, the range is larger. I mean, there is someone of 2 feet as well as there is one person of 5 feet. Okay. What will be the average? What will be the average mean for this? I'll call this x bar. Say, what is x bar here?
4.8.
4.8. And what is x bar here?
3 point.
3.8.
3.8. Can I make a statement in the first one? Almost everyone is having height nearly 4.8. Can I make the statement?
No, sir.
No. Can I make the statement everyone in the second set is having the height nearly 3.8?
Yes.
Yes. So the what we can say, the validity of your or the reliability of an average depends upon the dispersion of the data. Okay, I'll just write down this statement. This is a very strong statement which gives the importance to this complete unit. So reliability of average, reliability of average is more if dispersion is less. If dispersion is less. So our name of this topic is measures of dispersion. Measures of dispersion. So what we are going to learn here is we will learn different tools by which we can measure the dispersion in the data, and once we have the measure of these dispersions, what we can talk about is the reliability of your average. So how much reliable your average is, whichever you are using. So maybe you are using mean, whether you are using mode or you are using median or whatever. So how much you can rely on that average? Because average, we have seen that whenever we talk about the central tendency, the previous chapter, so what we studied was the measures of central tendency. There were different central tendencies. The central tendency, by way, I mean, can be mean, median, mode, harmonic mean, geometric mean, whatever. So that we were calculating, and now what we are going to learn, we are going to learn how much reliable those central representatives are. So what you have done is, when you take an average, what you do is you take out a representative of that data, and what you are going to do is you are going to do the calculations depending on that representative. Okay, so you must always know how much reliable that representative is, and that is given by the uh, dispersion. Fine. So first and very important one, when I asked about this set of 6 people here, so someone said that the values in the first set are having more spread. Okay, so we can see that the spread for the first, say, 5 people is more, whereas the spread for the second 5 people is less. Okay, and a very first and important thing here is that the range. While studying the first unit, we saw what is range, and range is the best estimate when we are going to talk about the dispersion. The range. So if range is more, right? If the range is more for a certain data, we can have a rough estimate. I mean, I can say that yes, this is widespread observations. Okay, so if L is the largest, if capital L is the largest observation, and S is the smallest observation. S is is the smallest observation. Then the range, then the range is equal to L minus S. And the corresponding relative measure, and the corresponding relative measure is, so coefficient of range, coefficient of range is equal to L minus S upon L plus S. So, okay, a small remark over here, because as you can see, we are just considering the observation. Say if you have a frequency distribution, the continuous frequency distribution, where we have the class interval. So in that case, what we need to do is we need to take the class marks for the first and the last interval. Okay, so small remark. For continuous frequency distribution, so small MCQ type question I can always ask, what is the range or the coefficient of range for the given distribution? Distribution mid values of first and last class are taken to be are taken as largest and smallest. So this is the first measure of dispersion. Yes, any benefit of this, or what you can say, is there any problem in this? Can it be used? How much good this measure of dispersion is, you think? Is it good? I mean, do you feel that yes, it is good?
No,
Why?
because it just gives us the uh, range as in the number of observations or something, like the first and the last limit it can give us, but not
So
all the values or something.
so it does not depend on all the values. Okay. So as you can see, if I have say a group of 6 people, then the range is good. I mean, okay, we can talk about it. But if your sample is very large, okay, and in that you are calculating out the range, then it may not be good in that case. Very big demerit, I can say, that it is not based on all the observations. Okay, so it does not give proper idea regarding variation between the extreme observations. Okay, so that is one of the demerit. And merit is that it is very easily calculated. I mean, you can just find out the largest, you can find out the smallest, and you can actually give the uh, range. Okay, so that's why what we do is we move on to another measure of dispersion, and which is mean deviation. We have seen the word deviation. Okay, so the moment we talk about the dispersion, we discussed that it is the extent by which your data is dispersed in a certain uh, plot. Okay, so a simple question arises: from what you are calculating the deviation, right, or the dispersion? So we are making a statement that it is dispersed, but from what it is dispersed, right? Now this statement makes perfect sense. Okay, so in the similar manner, what we do is we are going to calculate the deviations from where, the deviations from the mean. So the definition for this is the arithmetic mean arithmetic mean of absolute values of absolute deviation of absolute deviations from any average. Mean median or mode is called mean deviation about respective average. And depending on this, we can quickly write down the coefficient of the mean deviation. I will abbreviate this as MD. Mean deviation about some average. About average. In by average, I mean either mean, mode, or median. So mean deviation about average, about average upon the average. Okay, so whichever average we consider, depending on that, we can always write this down. So the first case, mean deviation about mean. Let's talk about mean deviation about mean. Mean deviation about mean. Yes, anyone? We'll discuss the cases. Say first one, the raw data. What will be the formula? Read the definition carefully. Arithmetic mean of absolute deviations from any average. So I am calculating now mean deviation about the mean. So I need to take the arithmetic mean of absolute deviations from the mean. That will give me the mean deviation. So mean deviation will be equal to
xi minus x bar, mod of xi minus x bar.
summation mod of xi minus x bar. I is running from 1 to n divided by n, right? So what is xi minus x bar? It is the actual deviation from the mean of certain observation. Deviation. So we are taking the mean of the deviations to give us the mean deviation. So second, for discrete and continuous, what will be the formula? Discrete and continuous. Continuous frequency distribution. Mean deviation. Someone else, then Manas. Someone else, Yash, Harshit, Hasnain.
xi minus x bar upon f into f.
Xi minus x bar into
Submission of f mod xi minus x bar upon submission of f.
yes, summation xi minus x bar mod upon summation f. I is running from 1 to n. I is running from 1 to n. Exactly. Look, in discrete frequency distribution, we have actually xi's and fi's are given, so there's no problem. For continuous frequency distribution, our class marks are going to be the xi's, and once we are done with this, what will be the coefficient of mean deviation about mean? Coefficient of mean deviation about mean is equal to mean deviation about mean upon what?
X bar.
About upon mean. So this is the complete thing about the mean deviation. The same thing I can calculate about mean deviation about the median. I can also calculate the mean deviation about the mode. I won't write down the formula for mode. For sure, I'll write down for median. So the mean deviation will be summation xi minus the median upon n. I is running from 1 to n. Coefficient of mean deviation about median. Coefficient of mean deviation about median is equal to mean deviation about median upon median. About upon median. Same thing you can write about the mode. Fine. So I'll solve one example. Obtain mean deviation about first one, mean second, median, and the absolute measure of dispersion in each of the cases. And absolute and coefficient of, by absolute I mean coefficient of mean deviation. In each case. So I'll directly write down the table in the vertical form for saving our time. So class is 2 to 4, 4 to 6, 6 to 8, 8 to 10. And the frequency are 3, 4, 2, 1. Yes, tell me now. Which columns are needed?
Class mark mainly.
Class marks, xi. So that are 4 plus to 6 divided by 2, 3. It will be 5, 7, 9. Next column. Latasha. Nishtha. Parth. Saurav. Shivani.
Hello, sir. Can you hear me?
Yes, I can hear you. Tell me which column is to be made now.
Okay. X bar.
So can I say?
Yeah, okay. Yes, you can speak.
XIFI.
Exactly. This is for next one.
XI minus X bar. Mod XI minus X bar.
Okay. Mod of xi minus x bar.
And the next is Fi bar XI minus X bar.
Phi into xi minus x bar.
X bar.
Fi xi minus x bar. Anything else?
No, sir.
No. Okay. What about the median? What you are going to do about the median?
Cumulative frequency CF.
Cumulative frequency. CF less than cumulative frequency curve we will need. Cumulative frequency. So from that we'll get the median. Then same thing, whatever we have done for the mean, the same thing has to be done for median. But first of all, let me just please raise your hand whoever have got the scientific calculator. I told you to purchase one scientific calculator for yourself. If you have got it, then I'll tell you the way by which you can enter the function, and the number of columns will be reduced. Only 4 to 5 students are there. 3, 4, 7. Okay, fine. Okay, so let's go ahead. Whoever have the calci, please follow the steps. So what we are going to do is we don't have to. I mean, for xi fi it is very much easier. I mean multiplying, so it is not so much difficult to do all the calculations. But still, we will follow some certain steps in order to understand the procedure. Okay, by which you can save your time while doing the calculations. So what you need to do is press alpha and choose the variable, the first one, then press x. Okay, then again you need to press alpha, and then you need to press y, and there is a multiplication here. Okay, if you press it or not, the calculator is by default going to take multiplication there. So once you do these calculations, you will see x into y on your screen. Okay, someone please respond yes or no, because I'm not using the calculator here.
Yes, sir.
Yes, you have got x into y. Now what you need to press is this is a very crucial step, CALC button, which is below the shift, I guess. So once you press this, what you will see on your screen is x equal to question mark. Is it there, Manas?
Yes, sir.
Yes. Now give the value of x. What is the first value of x? So you are going to give, press 3. Now you want your cursor to shift on the value of y. So once you press 3, and then you need to press equal to. Yes, press equal to. So now it will show you y equal to question mark. Do you see y equal to on your screen?
Sir, earlier it was showing y is equals to question mark, and now it is showing syntax error. Empty placeholder was found in input expression.
Manas, is it same with you?
Yes, sir.
So it is showing syntax error.
Yes, sir.
So it asked you the value of y first. Is it so, Hasnan?
Yes, sir.
Yes. So give the value of y. What is our y corresponding to? 3, na? I mean frequency. Y corresponds to frequency in this case. You
Yes,
give the value of y, then
sir.
it will
Yes,
ask.
sir.
Huh.
I've given the value of y as 3, and it didn't ask me the value of x.
So you have to press equal to.
Sir, I had. So let me try once again.
Yes, please try this once again.
Sir, for me it's fine. It's asking me the value of y.
Yeah. Have you got both of you?
Yes, sir. Yes, sir. It is asking the value of y.
Yes. So you give the value of y and you press equal to again. Every time you press equal to, after this when you will press equal to. So you have given the value of y, then
It
you
is
will
showing 9.
press equal to.
9.
Okay, so it shows you 9. Again press equal to, it will ask you new value of x.
Yes, sir.
So you need to follow the same procedure.
Okay.
So you don't have to put the function again and again, and you just go on giving the values of x and f. You follow the complete procedure by pressing equal to again and again. Keep giving the values of x and f parallelly, and you will go on getting the values. Is the method clear to the people who are having calculators at least?
Yes, sir.
Yes, sir.
Yes. So let's write down the column. So 9, 20, 14, 9. It's quite easy. So now what we can do, can I reduce the number of columns? How we will reduce the columns? Can you use this procedure, and because of this calculator, can you decrease the number of columns now? Which column can we reduce? Is there any point in taking this column when I can enter this function directly in my calculator? Okay, so this column can be reduced, the xi minus x bar apart. Okay, so this I can always remove. Fi xi minus x bar I can take, and I can directly enter this function in my calculator. So that's why one column is reduced. Similarly, I'll directly make fi xi minus median column. So I'll rub this part now, whichever procedure I have written, considering everyone is clear with the use of calculator now. So because we need to find the mean as well as the median here in order to get the deviations. Fine. What is summation xi fi?
52, sir.
30,
52.
52,
52.
52. So x bar is equal to 52 summation xi fi upon summation fi. Summation fi is 10. So that is x bar is 5.2. Also, we will find the median here itself. So less than cumulative frequency. So that is going to be 3, 7, 9, 10. 10 by 2 is 5. The class just exceeding 5 is this one. So this is just greater than 10 by 2. What will be the median now? What is the formula?
L plus n by 2 minus CF into H5.
L plus n by 2 minus Cf into h by f. Let's put the values. What is the lower limit of your median class, which is 4? N by 2 is 5 minus what is the cumulative frequency of previous class, it is 3. The height of your class is 2 and the frequency of your class is 4. So the median is equal to
5.
5. So we have got the median, we have got the mean. Now let's go for the coefficient of mean deviation or the mean deviation about mean and median. So we have class intervals, or I will directly write down the exercise now. No need to write down the class intervals. Exercise are 3, 5, 7, 9. The frequencies are 3, 4, 2, 1. Now, which column I said we need? Fi mod xi minus x bar. Right? For mean deviation, we need this. For deviation about the mean, what I need is Fi. Also, we have the value of x bar. So let me just put that. So again, as in the function, we'll only need 2 of the unknowns. Xi minus 5.2. Similarly, Fi, Xi minus 5. Can you put the function? Try it. Once you have entered the function and you get the first entry, let me know. Harshit,
Yes, sir.
yes, you have entered the function. Are you able to do the same thing in your calculator?
No, sir, it's currently not working. I'm trying it to.
Okay. Be careful of mod. Ajay,
Yes, sir.
you're able to do it?
So I don't have calculator. I am doing by rough work.
Okay.
Yes, sir. First one done.
Yes. Varun, you have done it on calculator. You have entered the function.
Yeah, yeah.
Yeah. So what is the answer for what is the first entry?
3.6.
3.6.
Yeah.
No, no, no.
6.6.
6.6. Please check it, Varun.
Yeah, sure, sir.
Next one. Three point six, 3.8. Hasnain, are you able to get the values like this in your calculator?
So no, sir, I'm not getting it. I'm getting absolute values like 9 and all that.
So do one thing, press mode and press 1 and then do the same thing.
Sir, I can't see your screen.
Sir, mode, that is MODE mode.
No, 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 no. Yes, MODE mode button. There must be a mode button, right?
Yes, sir.
Yeah.
It's showing so many functions.
Yes, so the first one you need to choose, the compute one.
Compute. Chosen
Sir,
limit.
I am unable to see your screen, sir.
Yeah, just a minute.
This general calculations, math, statistical and distribution calculations, complex, base and table. So which one we have to choose?
Uh, the first one, general calculation system.
Okay, sir.
Then try to do it.
Yes, sir.
Yes, sir. So the next column, can I say?
Yes, please.
Okay.
6,
6.
0, 4, 4.
4.
What is the summation fi xi minus x bar? 14.8. The sum is, I'll write it down here, 14.8. The next one is 14. So mean deviation about mean is equal to 14.8 divided by what is it?
5.2.
Sure. We are using the mean deviation. We are not calculating coefficient of the mean deviation,
Sir, summation fi 10.
which is 10. So this is 1.48. Mean deviation, coefficient of mean deviation about mean. This is equal to mean deviation about mean upon mean. What is our mean? 5.2. So this is 0.2846. 0.2846. The mean deviation about median is equal to, that is summation fi xi minus median is 14 upon 10 is 1.4. Coefficient of mean deviation about median. This is going to be 1.4 upon, what is the median? 5. What's the answer here?
0.28.
0.28. Okay, so these are all the calculations. So first of all, you should always verify what things you need to find out from the question. Accordingly, we should be able to make the columns, and then at last we'll be able to find out the coefficient of mean deviation about whichever average we are calculating. Fine. That's it for today. If you have any difficulties, please ask.
Yes, sir.
Uh-huh.
Right now, I didn't have the scientific